I wanted to look at permutations worksheet number 12 with you because that's another interesting problem. We went over this in class, but I just want to try it again. So number 12 said that we have four couples and they have seats in a row for a concert. And how many ways can they be seated if there's no restrictions? And Sarah and Delilah totally figured this out, and many of you did, and I stubbornly didn't read the problem as closely as you did, so forgive me. If there's no restrictions, except that my marker doesn't work, ugh, that means that these 8 people can just like sit wherever they want. 2, 3, 4, 5, 6, 7, 8. That means that I have 8, and by the way, let me just write that I have 4 couples, which just means 8 people. So no restrictions. Doesn't matter where people sit. Well, it seems like I have 8 choices for who can sit in the first spot. And that leaves 7 choices for who can sit in the next spot because one of them's already been used up. They've been chosen. That leaves 6 people left to pick who sits there, which leaves 5 people, which leaves 4, 3, 2, 1. This is classic factorial, so this is just 8 factorial. That's my answer. If it doesn't matter where people sit, that's what no restrictions means, then this is how you can line them up. It's like lining up books on a shelf, people in chairs. Now, if they want to stay as couples, if they want to stay together as like couples, then think of it as, well, really, I really only have 4 spots that these couples can take up. Within the spot, there's the 2 people together, but ultimately, if the couples want to stay together, I've got 4 ways for the first couple to sit, which leaves 3 ways for the second couple to sit, which leaves 2 ways for the first couple, which leaves 1 way for the last couple. I may have said that incorrectly, but I hope you know what I meant. So we have 4 ways that we can pick a couple. Once that couple is seated, there's only 3 couples left. So there's once that next couple seats, there's only 2 positions left for the other people. Couple sits down, that leaves 1 place left. This is like also like a race. If you come in 4th place, 3rd place, 2nd place, 1st place. Now the thing is that within these couples, if they're like, I wanted to sit on the left, then you have to allow them an option of moving their seat, which is why that means that we actually have another way of, they actually can change their spots. So I'm going to just like make a box and go like this to imply that they change seats. That's supposed to be a double arrow, sorry. So they're like, you can think of it as person A, person B. That might make it easier, actually. So here we had person A, person B, and then the other choice is person B, person A. And here we can have C and D, and then we can have DC. And then this could be person EF, and then, or maybe FE, and this could be A, B, C, D, E, F, G, H, or HG. So these are the options that we're allowing for. But we also had 4 ways they could sit, 3 ways they could sit, 2 ways they could sit, or 1 way they could sit. So ultimately, this is 4 factorial plus 4 factorial. That is the answer, 4 factorial plus 4 factorial. I think we figured out in class that this is 4 times 3 times 2 times 1, which is 24, plus 24 equals 48. So that's a tricky question. Good luck with this. Thank you.